Hello, my name is John. Thanks for stopping by my blog. Today I'm going to talk about electrical current and why I think the currently most popularly accepted theory on how current moves is wrong. We're going to start today with another analogy. Most people think that a good analogy for current is like a water hose, where water flows through the hose, where the hose is the wire, pressure is the voltage, and water is the flow of current. Well, I'm here to tell you today that current does not flow. Only voltage flows. And I'm prepared now to explain why. You look at this general circuit with two switches on either side of the battery. When those two switches are thrown simultaneously, voltage will begin to flow through those wires. Consequently, each section of wire that gets hit by voltage is going to start eliciting excited electrons. As we watch both switches being closed, we're going to see what appears to be voltage and current flowing together around the wire to the opposite end of the battery. This is why people think current moves. Now I want to run that same animation with a little different twist. This time I want you to consider that the blue part, which is supposed to be the current and the EMF field around the wire, are stationary, and only the voltage is what is traveling along that wire. That's my theory. And it goes kind of like this. Now just imagine the blue part is stationary. That current is created in that particular spot where it's created, and that current stays in that particular spot. The current does not move in this theory. The idea that the current is moving is only an illusion. The current's being created where it's being created, and it stays right there. That current is not moving. The voltage is moving, causing the current to erupt in its stationary place. A better analogy to explain how current is created in place and stays in place as long as there's a closed circuit with positive energy flowing through it is this line of trees, which we will assume are copper atoms inside of a copper wire. When voltage is introduced, it excites the electrons in the tree. The tree catches fire and releases heat. So in this analogy, the tree is a jiggling electron. The heat is the current it produces, and the flame is the power or the voltage. Earlier I said that the trees represent atoms, copper atoms in a wire. Let me amend that to say possibly clusters of atoms, but we're still talking about a very narrow constricted area of copper atoms in each section of wire as the positive charge flows across. Now, as you can see by the diagram, the little wavy parts above each fire is the current that would be in a wire. And as you see, it doesn't move from side to side. It doesn't travel along the wire. It stays put where it's created. And it only exists there. It doesn't move micrometers. It doesn't move millimeters. It doesn't move anywhere. The only thing that moves here is the voltage. And the voltage in a closed circuit is what incites current to be produced. The current is not flowing. And here we have a schematic of a circuit similar to the one we watched earlier, only this side, one of the switches is still open, the negative side. The positive side of this switch is connected to the positive terminal of the battery. Therefore, this entire main wire is going to be pre-charged. It's a pre-charged state. In other words, that means that voltage is already present on the main length of that wire. It's not producing current, it's not producing an EMF field because the circuit is still open. That switch on the negative side is not closed. When we close that switch, we're going to have a total of about 6 to 12 inches of length for the voltage to continue its path. That's going to happen almost instantaneously. Ergo, when that switch is closed, it's going to have about 12 inches to travel. The voltage will have 12 inches to travel at the speed of light, which is like 1 nanosecond or less. So almost instantaneously, that entire wire is going to be charged and ready to start making current at each and every spot all across that wire, and every atom across that wire is going to start producing current simultaneously. And this is going to be the result, because as soon as that negative switch is closed, less than a nanosecond or so later, we're going to see current being created over every part of that line at once. All of the lights are going to light at once, instantly, almost as soon as that switch is closed, minus the 1 nanosecond and minus the few nanoseconds it takes for the EMF to form by the excited electrons. So that, my friends, explains a recent experiment and why the current showed up at the other end of the circuit instantly. And here's our tree analogy once again to show that pre-charged state. Here you can see all the trees lined up, and voltage is present on all these atoms, okay, these copper atoms that the trees represent. It's already there. It's not producing EMF, it's not producing current, because the circuit is not closed, okay? But what happens as soon as we close the circuit, we throw that switch on the negative side. Now, because the entire length of wire is already pre-charged with positive voltage, and the switch hadn't been closed yet, it was not creating current, it was not creating EMF fields. The electrons, copper electrons, were not in an excited status. However, once that negative switch is closed and the circuit is closed, at that point EMF starts to be created. The electrons get excited and start jiggling. That creates the EMF. The stronger the EMF gets, the more excited the electrons get, because the EMF is pushing inward, has a magnetic field pushing inward toward those electrons, and they become super excited. So it takes a little bit of time, a few nanoseconds maybe, for the entire line to light up. But this is what happens when you close the switch on a pre-charged line. It starts producing current across the entire line. And that's the theory. Now you should know that I'm the type of fellow that changes his theories quite often. The whole idea behind theory is to advance science, and you got to throw a bunch of spaghetti on the wall to see if it sticks. You know, you can't get discouraged when you get a whole bunch of spaghetti that doesn't stick. You got to keep trying. This is just an attempt. Please understand that. Don't become upset or personally involved with how it might differ with your own theory. This is just an attempt to advance science. That's all it is. Now, the reason I show you this particular video and how I formulated this particular theory on how current does not flow is because of this reason. A fellow named Alpha Phoenix, a YouTuber, did a test on air or on his YouTube channel with 1,000 meters of wire to determine how fast current flows along a wire. Well, in his test, it was a little bit flawed, and I don't think most people realize that. Before the test began, the 1,000 meters of wire was already connected to the positive side of a battery. Okay? Now, the negative side was open, which means that the circuit was not closed. Just the positive side of the battery was connected prior to the test. Well, that means, as I've showed you, that the entire line was pre-charged with positive voltage. And when the negative switch was closed, it only had about 10 or 12 inches for the rest of the electrical charge, the positive voltage, to travel to the battery. How fast does that happen in the speed of light? Very fast, I assume. I don't know, less than a nanosecond maybe. So as soon as that connection was made, all across the entire wire, voltage and EMF started to be created at that same time that switch was closed. It was instantaneous. And if you watch his video on that, you'll see that what he calls an anomaly is a very small, immediate bit of current. As soon as he switched, you could see on his timeline where the switch was thrown and the current was immediately present at 500 meter interval on the other side of the circuit. So there was zero time for that voltage and that current to begin creating current. There was 0 seconds. And this video just attempted to explain why that happened. Once again, thank you for listening. I hope this makes sense to you. I think it's intuitive. I think it's very believable. I think it's illogical. And but like I said, it's just a theory. And theories are nothing but hypotheses that you can change anytime. Okay, they don't fit the model. They don't fit into the natural laws that we observe as a fact. I don't think this one falls outside of natural laws, but that's my personal opinion. I think it's very intuitive. I think it's a very logical understanding of how things work. One thing I will say is that we've held the current theory that, I mean, current, that's the wrong word to use. Our contemporary model that we use is that current does flow, and we've had that for 120 years. So the real question is, how much longer are we willing to wait before we realize, hey, we don't have Jetsons magnetic magical flying cars to get us to work and back. We don't have spaceships that travel at the speed of light. We don't have 0-point energy. There's something holding us back, in my opinion, from those things. And without hypotheses, without new theories, without exploring the possibilities, and I mean the endless possibilities that are out there, we're not going to accidentally bump into an answer, a solution for fossil fuel burning, unless we start changing hypotheses in our theories. And that's all theories are. They're just a bunch of guesses, guys. Okay? So let's just jingle the guesses around a bit. Let's throw a few guesses in there. Let's take some spaghetti, throw it against the wall, and see if it sticks. I guess in the end, what I'm really asking is to not be offended by this video, which is simply projecting an alternative hypothesis. Please just consider it. If you consider yourself a scientist, that's really your job, okay? Because what we need to do is find solutions for the garbage we have been throwing into our atmosphere and into the soil for the last few hundred years. And honestly, we're only going to achieve that by commiserating together on those awful things, and by collaborating together on new, fresh ideas that might possibly lead us to an answer to all of our problems. Now, I don't know if understanding that current doesn't flow will help in the long run over the centuries for future scientists to use that information in order to create 0-point energy. I hope we can do it during our own lifetimes, but it's looking kind of doubtful. Honestly, I think a lot of people are so married to their own theories that they were taught that they refuse to accept anything else. I think that's bad for science. Honestly, I do. I think we need to continue looking at new theories, new suggestions, new hypotheses constantly and continuously, so that we can become a better society, so that we can improve our atmosphere, so that we can travel in space at miraculous speeds that will get us places for further exploratory reasons. And you know, and it all starts right here. It starts right here with this hypothesis, and any hypothesis that we can add that will change our understanding of how things work in the real world, that could possibly lead us to advancement in science. And that's why I'm excited. I feel God put me here. He gave me this inquisitive nature and this reasoning nature, which I consider to be great logic, for a purpose. And if I don't share this, if I don't put this out here, then I feel that I'm failing myself. I'm failing what God put me here for. Honestly, that's how I look at it. So, and I hope you look at your scientific endeavors as the same way. If we can stop pollution, if we can stop deaths by asthma or whatever else this terrible stuff causes, let's do it. Let's put our minds together. Let's make it happen. Thanks for stopping by. I'm John once again, and I'm out.